Hi Nutrition 101, so welcome to the second part of Chapter 1, which is the role of nutrition in health. So last time we talked a little bit about each of the nutrients. So we have carbs, protein, and fat are our energy providing nutrients. Water is our other one to round out the 4 of the macronutrient classes. Vitamins and minerals are our micronutrients. And vitamins, carbs, protein, and fat contain carbon, so they're considered organic molecules. Water and minerals are considered inorganic molecules. When we look at the functions of nutrients, they provide energy. They allow us to, ride our bike like the person over here. They also provide structure. So you can see that, about 6% of our body is made of carbs and other substances and minerals. A lean adult male has 16% fat, 16% protein, 62% water. The amount of fat usually goes up and the amount of water goes down as the amount of protein goes down. So the more fat you have on you, the less water and protein you do proportionately. So that would look a little different for different people. And then we need to regulate. We need electrolytes to, maintain water balance. We need to excrete some water to have a cooling system in our body. We have this guy sweating over here on the right. And then we have to make some hormones for regulatory processes and enzymes and coenzymes. So we have lots of different functions of nutrients. And as I mentioned, we'll be going over those in a lot of depth throughout the semester. So calories with a capital C. So we never talk about calories with a little c. That's a term used in chemistry. That's a 1,000th of a calorie. In nutrition, we talk about calories with capital C, which could also be called a kilocalorie. It's our unit of energy in food. So you need to memorize that protein and carbs contain 4 calories per gram. Fat contains 9 calories per gram, and alcohol contains 7 calories per gram. So these will just be things you need to know throughout the semester for math problems and things like that we'll be doing in class and for homework. So when we talk about nutrition, a lot of times people think of malnutrition as being undernutrition. So we think of starvation, we think of being malnourished as not having enough food, but you could also call malnutrition overnutrition, which is too much of a nutrient or nutrients or calories. So you could say that the obesity epidemic is causing malnutrition in terms of overnutrition, and our lack of nutrient density in our diet is causing malnutrition in terms of undernutrition, of too little vitamins and minerals and fiber. So disease genetics. In nutrition, we talk a lot about this because you're dealt a certain hand of cards, right? And then you need to learn how to play them. And that hand that you're dealt is your genetic code, right? So some diseases occur when a single gene is mutated. So that would be things that you're born with, like cystic fibrosis, sickle cell anemia. But most diseases, and these are the nutrition-related diseases, result from a combination between genetics and the environment, where genes can increase your risk. So if you have a family history of obesity, heart disease, and diabetes, you're at increased risk. But you can do some things with diet and lifestyle to prevent that from happening and to prevent those diseases from occurring. So this is just showing that in a little bit different way. So we have diet and lifestyle, and we have our genes. And so throughout this semester, I'm hoping that you'll all be able to take something away personally from this class. So thinking about, okay, what hand of cards have I been dealt, and how do I play them to the best of my ability to make sure that I live the longest, healthiest life possible, right? That is the goal of Nutrition 101, to teach you what we know in science right now to help you to do that. So there's a whole field now called nutrigenomics, which is the study of the interaction between genes and nutrition. So what we eat actually can change the expression of certain genes. And so in the future, we might see totally personalized nutrition. So I'm just prescribing everybody a diet based on their genetic code. We're not quite there yet, but we are starting to learn that different individuals need different things due to their genetics. So that's something we'll take into account as we go through the semester. So when we look at a healthy diet, there are really a few different components. So there's variety, balance, moderation, adequacy. So when we're looking at this variety, balance, moderation, and adequacy, this is what we mean. Variety, eating foods from a variety of food groups, and eating a variety of foods from within each food group. So you can't eat French fries all day and call that meeting your vegetable needs. You know, you can eat a French fry or two, but you also want some spinach, some tomatoes, some summer squash, some carrots, you know, lots of different colors, right? When we say paint the rainbow or color the rainbow when we talk about vegetables, it's because they contain a lot of different nutrients and phytochemicals. And then you can also decrease toxins from, you know, maybe certain foods will absorb more toxins than others, and so you can decrease the toxins that way as well. Balance can mean three different things. Balance unhealthy choices with healthy choices. Balance calories in and calories out, so you balance the amount that you move and with the amount that you consume. And then you balance foods within food groups. So the benefits of this, you have a wider variety of nutrients and you have some weight control. And then we have moderation. So moderation, you know, you really want to think about, all right, am I eating a pretty nutrient-dense diet? Am I avoiding too many empty calories? And am I avoiding too much of anything in general? You know, even though cans of tuna are, you know, a healthy food for some people, maybe you probably don't want to just eat cans of tuna all day, right? So you want moderate consumption of everything, including portion sizes and each food, even if it's a super nutrient dense food. So when we look at keeping weight stable and look at this concept of balance, you really need to burn the same number of calories you consume. And extra calories can be balanced by increasing physical activity. This isn't as easy as we would like to think it would be though. So, you know, if you just make the choice to have a 16-ounce mocha frappuccino instead of an iced coffee, you have to increase your energy expenditure by 370 calories. And that would be jogging at a pretty good pace for around 30 minutes. If you had a Big Mac for lunch instead of a smaller portion-sized burger, you'd need to increase your energy expenditure by 300 calories. You'd have to carry your clubs around the golf course for, you know, a whole hour or so. And so when we look at, you know, these different choices, it's really hard to just exercise your way out of a bad diet. You know, you'd be needing to exercise all day. And so when we look at exercise and diet, yeah, exercise is a real key component for a healthy lifestyle, but you really need to pay attention to what you're eating. You really need to pay attention to those added sugars, those solid fats, and the nutrition. How much nutrient density can I get into each of my meals and snacks? So when we look at nutrition, you know, you've all seen this scientific method, even if it was in elementary school, you know, 50 years ago or something. But when we look at the scientific method, this is how we discover new scientific information about nutrition. So we observe something. I might observe that half of you are falling asleep in my 8 a.m. class, right? I hypothesize that that is happening because you're tired, because you didn't eat breakfast, and you're hungry, right? So I could conduct an experiment where I fed my class, right, and see if everyone stays awake. And then my theory, if you all stay awake, is going to be that, you know, maybe breakfast eating keeps students awake in class, right? And so that's just a theory, though. I can't say that that's a truth. And the problem with nutrition is we take these theories and we just talk about them as being truths. So, you know, there's lots of different types of studies you can do with nutrition. So we can take blood samples, we can do animal studies, we can, you know, do studies where we take data that's already available and compare it to other data. We can do behavioral studies. My research was on food decision making in kids. So I sent them all to the grocery store with $3 to see what happened. So that was kind of fun research, a little messier than, you know, animal research that can be kind of neat and pretty, but still really fun. So when we look at, you know, different types of studies, there's lots of different types of studies that we conduct, and we have to conduct lots of studies to have a theory become what we consider a truth, right, in nutrition. However, what ends up happening is that there might be like a study done with 5 or 10 people, and then a product made resulting from that study, and then results reported by marketers in a really convincing way to say, hey, you know, you lost 4.5 pounds of unwanted fat. You should take, you know, this pumped up power boost to boost your strength and maximize your mass. So when we look at how nutrition is reported to us, a lot of times it might be based on, one of these studies, right? Instead of multiple studies that are examining nutrition in a really comprehensive way to create a truth about it. We also have a lot of convincing photos and things like that. We respond to photos really well. A lot of things like, before and after pictures might be different people, or they might be taken on the same day in different lighting. There's a lot of exposure coming out in the social media lately, which has been pretty encouraging. But we need to, take these with a grain of salt and really identify the nutrition information that's being fed, no pun intended, to us through the media is really just a glimpse at what's going on. So there's a lot more going on in terms of research, in terms of data that's being discovered versus what you end up seeing, on a diet theory book or on Dr. Oz show or something like that. So, this semester we're going to be really learning how to debate, how to examine, how to assess, how is this good nutrition information, and what information do I need that's more to help me decide whether or not this is a good, product or pattern to follow or something like that. And so when we look at the limitations of single nutrition studies, you really can't take one study, as I mentioned, and create a truth out of it. And a lot of times we're taking studies done on mice, it's like, okay, all the mice died when they were fed their body weight in this product, so now it's going to cause cancer in people, right? We make these big leaps to make these claims about different food components just based on small amounts of studies. It's not that it's untrue necessarily, it's that it's a half-truth, and then people take that little half-truth and blow it out of proportion, like humans just tend to do, right? So that is the end of chapter 1. So make sure to review your notes, take your quiz, make sure you understand all the different essential components of chapter 1, look over that vocab, and please contact me if you have any questions about anything that you've seen today. Thanks a lot.